Hello everyone and welcome to Meet the Expert series. During these discussions, we will be interviewing technical leaders within Java Technology Center. Today, we have the privilege of having Prashanth JavaWeek, a senior technical leader within Java Technology Center who has over 12 years of industry experience. Prashanth has multiple patents within the area of Java Virtual Machine. Thank you for taking your time out for this interview, Prashanth. Tell us about yourself, your background, and the work you are currently involved in.
Hello everyone, I am Prashanth from Java Technology Center at IBM. I started my career in IBM in 1998 as a level 3 software engineer in OS2 group. After 3 years of experience in OS2 group, I moved on to Java Technology Center in 2001. Since then, I've been lucky to be involved in various aspects of Java at IBM. Started as a level 3 engineer, servicing some of the key components like just-in-time compiler, garbage collector, and some of the core components of class libraries. Then I moved on to do some incubation to understand how Java behaves in a multi-core environment and see what can be done to improve the scalability and performance of Java in multi-core environments. Then I moved on to look into improving Java for virtualized environments, trying to understand what kind of things can be done from within the JVM to make it a better runtime for virtualized environments. These days I'm involved with Java 7 development of some of the key components of class libraries.
Java has come a long way since it was first used in digital devices. What has impressed you in monitoring developments in the Java technology over the years?
If you look at the recent past, the way performance of Java has grown over the last few years, you can see that it's really impressive. If you look at the actual data, you can see that in the last 5 years, Java performance has grown by more than 40 times. But if you actually look at the Moore's law, it was supposed to grow by around 8 times. So that's really impressive. It's almost 5 times better than what Moore's law predicted. So for me, that's one of the very impressive things which has been happening in the Java world for the last few years. And a lot of that is credited to the competition, healthy competition we have within the Java vendors. If you look at the future developments happening in the Java technology, some of the changes happening in the landscape like cloud computing, multi-core systems, and alternate languages, you see that all these have a huge bearing on Java simply because Java is required in this future landscape as well. So all this provides a great opportunity for JVM to do a lot of innovation and improve itself to be the number one technology in all these areas. So all this makes a JVM to be an interesting place to be in and a lot of exciting days ahead.
Java's execution model is built for parallelism. Could you please talk about some key innovations in the virtual machine and just-in-time compiler to exploit parallelism?
Yeah, sure. If you look at the IBM Java in terms of where all it is used, you can see it running on systems starting from mobile phones to very high-end servers. So you can imagine how IBM JVM is designed to be a very scalable system. That is one of the main reasons why several components of JVM are very highly scalable. If you want to talk about some of the more specific components like garbage collector is well equipped to run on very high-end systems, making use of all the resources available on the system by spawning right number of threads to be running on the system to perform garbage collection in optimal amount of time. Next, I will talk about just-in-time compiler component, which generates code which is appropriate for the hardware it's running on. So it knows what kind of parallel system it is running on and generates code for the same. Apart from just generating the code, the way it generates the code is also optimized for the hardware. A simple example is it can parallelly generate code for several methods depending on number of cores available on the system. Apart from that, class library, IBM has done a lot of work on class library to make it concurrent and thread safe so that customers can directly benefit out of the optimizations done in the class libraries. So in summary, all components of the Java stack are optimized for the multi-core environment to take advantage of the additional hardware and capability available on the system.
What are some of the key optimizations in the JVM for Power 7 and multi-core scalability?
Like I mentioned earlier, we have IBM JVM is highly optimized for multi-core system, and Power 7 being one of the top-end multi-core system. A lot of key components like GC, JIT, and core class library components have been optimized for multi-core. Apart from that, Power 7 provides several special instructions which we are taking a lot of advantage of and bringing a lot of optimization for workloads which exploit floating point and decimal conversions and stuff like that. Apart from that, specific attention has been given to utilizing the cache size appropriately. So JVM is highly tuned to ensure that caches are utilized appropriately. Another specific optimization we have done is to ensure we remove unnecessary locks in the class library and other JVM components to ensure better scalability is provided on the Power 7 kind of systems. So if you look at the actual performance, we can say that Power 7 system is almost 3 times better than a equivalent competitor's system, and that has been proved by some standard industry benchmarks.
Cloud is the buzzword in technology today. Please share some insights on the integration of Java with the hypervisor and operating system.
Very good question. As you know, cloud is the future of IT industry, and soon we'll see most of the services and products delivered via cloud. And it's very important for all the products and services to think about how they can optimize for cloud. And Java being one of the core components of several products, it's important for Java to adapt for the cloud, and hypervisor being one of the core components of cloud. It's important that IBM Java understands that it needs to run on the hypervisor in an optimized way. While running on hypervisor in a cloud environment, one of the main things is infrastructure is dynamic. Traditionally, JVM has been built for on-the-metal configuration where your resources is fixed. So with this dynamic infrastructure coming into picture, JVM needs to adapt itself to be reacting to the dynamic nature of the resources available for itself. So that's one of the key things which JVM need to do to adapt itself for the cloud. Apart from that, cloud computing brings a opportunity where you have multiple copies of the stack running on the same hardware. So there's a lot of scope for sharing of data, code, and even some of the other resources. So it's important for JVM to think about how we can improve sharing and bring about improvements in the resource utilization, which is one of the key components, key aspects of cloud when it comes to delivering your services via cloud in a cheaper manner. So there's a lot of things to be done from the Java point of view to make Java a better runtime for cloud. I am personally involved in the incubation efforts to make JVM a better runtime for cloud environment. It's a very exciting piece of work I have ever done in my career. So I'm looking forward for a lot of exciting days ahead of me.
And finally, any advice for our readers and young developers who aspire to pursue their career in Java?
One basic advice I would like to give to young developers is to write lots of code. That's when you learn a lot and have fun with it. Enjoy writing code, and that's when you will get best out of any technology. That's the basic advice. Apart from that, I would like to say keep in touch with the developments happening in the technology by connecting to various technologies through various forums. Developer Works definitely gives you a very good platform to connect with various highly technical engineers in the world. So I would encourage you to do that. Apart from that, I would want you to remind that often people take this write once, run anywhere theory very seriously, and but while actually developing the and designing the code, designing your applications, it's important to keep in mind what is your target system. Without that, you probably most of the times will design and develop a system which is not well tuned or well developed for the target applications. So basically, I want to say have the bigger picture in mind whenever you are doing a job, so that the ultimate goal is reached in a successful manner.
Thank you, Prashanth, for taking time. It was great talking to you.